Hey everybody, purpose of this video is to get you through the ramp number 2 calculation. You guys were working on it in class, ran out of time. So we'll do it two ways. We'll do it the right way and the wrong way, because we were doing that in class. So we'll do it the wrong way first, because the wrong way is simple. The wrong way utilizes the hypotenuse as the run. So you can ignore this calculation for just a second. It calls the hypotenuse the run, and it uses the rise of 7 inches. So your wrong way would just be your 7 inches over the hypotenuse. Now that's 10.5 feet. So changing that to inches would be 10 times 12 is 120, and then a half of a foot is 6 inches, so that's 126 inches. 126 inches. So that doesn't make any sense till you put it into a decimal or a percentage, and I got about 5.6. So you can go ahead and call that 6% if you want to, 5.6 if you want to, whatever you feel like rounding to. So the idea is that the wrong way gives you a grade of 6%. Okay, and more on that tomorrow, I guess Wednesday, whenever you look at this, Wednesday, we'll talk about whether or not that's ADA acceptable. We'll come to that in class. The right way requires that you do a little more calculation. Let's put a line between them. Requires you to do a little more calculation because you actually have to calculate the run. So I slapped this computation up in class. I think that may have freaked a couple people out, and I don't want to freak anybody out. It's kind of the antithesis of what I'm trying to do mathematically. So what you can do, if you spend a lot of time with right triangles, which we have here, very often these values are called A, B, and C. I'm not a huge fan of that. I'd much rather have the context of hypotenuse, leg 2, and leg 1. So we established a formula in class today, and you guys actually had it from way back in the day. Leg 1 squared plus leg 2 squared equals the hypotenuse squared. So I mean, you learned that way back in the day at some point somewhere. The beauty of this is you can solve that equation for any one of the 3 variables. And the one we need to solve for right now is this guy. I think we were calling that leg 2. So in order to solve for this using the Lego method, we first have to move this whole thing over. So you end up with leg 2, sorry, Plint, leg 2 squared equals hypotenuse squared minus leg 1 squared. I'm kind of impinging upon the graphic here. And now, if you can take the square root of both sides, hopefully what you're realizing is we're doing the same thing here that we were doing in class with the numbers, except now we don't have numbers. Taking the square root of both sides, you're left with just leg 2, and you have to take the square root of this entire quantity. So you end up with the square root of the hypotenuse squared minus the first leg squared. And this is exactly the Lego method. Exactly the Lego method. So looking at this and looking at this, you see why it all stacks up. The hypotenuse squared is 126 squared minus the leg 1 squared is 7 squared, 7 inches squared. So once you have that, you realize that you get to the exact same result that you get here. This is a more generalized form. If you don't like generalized forms, you don't have to use it. Just make sure you solve it correctly. So you don't have to look at that at all if you don't want to. Too late, right? Sorry. So anyway, the right way to do this calculation would be to use that correct calculation. So you take that 7 inches over that computation, which I worked out to be, it's 125.8 inches. So rounding that, it should round to 126, but 126 is the same as the hypotenuse. We have to have at least a nod to the fact that it's different. So it is. It's 125.8 inches, which again is 6%. So, I mean, essentially, you're not getting any difference whatsoever in grade. I mean, it rounds to 6%. Right? Let's throw in the different number to see what it ends up being. 5.8. Yeah, instead of being 0.0555, it becomes 0.0556. So again, an imperceptible 10,000th place difference. And that was the point of today. Was for pretty small angles, not drawn to scale, but for pretty small angles, these are going to be very, very close to each other. As the angles get larger, then they're not so close anymore, and they start changing. So that's the first one. We'll do a second video for the top ramp.